Awesome. Last day, last half a day, last 3 hours. It's a
What
race
can
to
we
the
not get done
finish.
in 3 hours?
Yeah, it's race to the finish. We're in sprint mode now. So, it's all been kind of marathon mode the whole time, just kind of cruising along, and we're gonna probably stay in marathon mode. We're just gonna we'll just finish it out, and
Well, I mean, there's been so much this week.
yeah,
It really has been cool. And I mean, I'm kind of glad that it's coming to an end, but I'm also kind of sad too, because
right,
it's like, man, now I got to go out and do this and figure out all this cool stuff on my own.
right. So then that's kind of the idea that I hatched last week. Like I really think, kind of doing like a Twitch kind of a thing where we have them recorded, and I'll save those out to, because you can, once you have them done on Twitch, you can download them and put them on YouTube and all that kind of fun stuff. But try to create, a series of these things so that you always have a set of resources to kind of go and, like if you, like you say, you enjoyed this week, so you're comfortable with how I run things, and you can just, I think a lot of that's, if you find a resource, then I absolutely want to tap it for what it's worth. So Avi looks, yeah, I'm glad you enjoyed the last 2 weeks. I mean, I've had a blast too. It's been really fun. A couple frustrating points there where like things just weren't quite working the way they were supposed to work, or get into areas where I wasn't 100% comfortable. But I think for the most part, I'm happy that we've actually done quite a bit of really fun things. So it's been good. It's been good.
I'm almost ready. I just fixed my one SD card, so I'm gonna make a couple of copies and then I'll be ready to go.
No worries. That's fine. We'll do our normal kind of see what's going on and see how everybody's doing, and then we'll get moving. I had a card here that I just redid real fast, so that I had one. I thought it was ready to go, but it acted funny, so I just started over, which is, especially when you have new clean cards, it's nice that you have that option. Oh, I haven't turned on. That's awesome. Good job, Carrie. I should probably turn on SSH. Cool. Yeah, so we've got what, eight of you are here now. We still got, that's about half. So we'll, again, kind of let people get logged in and kind of roll from there.
So, Carrie, just kind of I noticed that this is a 32-bit operating system. Any reason why it's not 64?
Yes. The main operating system is meant to work on all Raspberry Pis. The original Raspberry Pis were 32-bit processors. They switched over, I believe, threes, like the first three, maybe the last two was a 64-bit. There is a 64-bit version that you can track down of the Raspberry Pi OS, and I believe OpenSUSE has a 64-bit version as well. So if you wanted to play with 64-bit processing and operations and stuff, then there are some options out there for you. The primary OS that they push out, like they really, one of the things they don't want to have, like somebody who comes across a 1 or has an early 2 to not be able to do things. Like they're going to be really slow, but they could still operate, right? Because they're still running the 32-bit versions. So there is a 64-bit version, and they did that. I mean, it's silly to have an 8 gig Raspberry Pi, right, and not have a 64-bit version. So that's, I think, yeah, that's definitely there. It's definitely out there. I haven't looked lately, like how to find it. I wonder. I'm gonna go look now. So thanks for bringing that up. Let's go down that rabbit hole. 64-bit OS. All right, Raspberry Pi, 64-bit OS for the Pi 4. So yeah, even on the Raspberry Pi page, it looks like there's a, they call it Raspbian InSpawn 64. That's that's kind of funny. It looks like Manjaro also has a 64-bit version. All right, so there's a to run 64-bit Debian Buster package on Raspbian RPI 4. You can actually run them on RPI 3s as well, because 3 is also 64-bit. Looks like there's quite a bit of finagling. I haven't really played with it, but there's quite a bit of stuff you can do around that, like just, and they,
It's not like we're hurting for anything to do with it, but I was just, since the Pis actually come, with
right.
that architecture, I was just kind of curious if there was a real reason why.
No, the reason for them sticking to 32 is that they wanted to run on all of the versions. So there's an official 64-bit kernel that you can, all right, so as the 64-bit kernel is getting more functional, there's an RPI update for the kernel. Yeah, there's a lot of finagling to get it functioning. It looks like you've got to kind of, you got to make some setting changes and do some strange stuff. And I haven't played with it. Not that it's, I think it's more just sticking with something that's simple for the courses and or workshops and things that we're doing. But so yeah, so it looks like, what do we got? Where did my console go? There it is. So 13, we're almost there. Most everybody's back. Haven't scared everybody away. That's good.
I have a question.
Good. Yes, ma'am.
Are there any user groups for specifically teachers using Pis in upper levels? I mean, I know a lot of the K-12s do. We do it with all kinds of kiddie groups, but I'm talking about people want to implement it like we're doing here in networking classes and.
Not that I'm aware of. In fact, most everything is geared towards the younger student. So
yeah,
that's a really good idea, actually.
Well, the problem is too, these kids are getting, the CSTA and a lot of these do a lot of good stuff, but they're doing prepackaged curriculum, and often the people who are teaching them don't understand how to recruit, or the fact there's so many different fields within IT. It's not just about programming. And instead of getting people excited about all the different options and things you can do, they're focused on teaching them Python to turn left and turn right.
Yeah.
And I'm so sick of that. And the CSTA standards has like 2 or 3 standards on networking, and that's it. And it's like, let's focus on data analytics. I'm like, hey, there's so much more than that. So, and the Pis when they're are used in very, I don't know. I'm just very disappointing.
Yes, I agree. And I mean, I think that's my hope this week was, right, first of all, right, as a drug pusher, I wanted to get you all hooked, right? The second thing was to kind of show that, right, it's not all about programming. We haven't done any real programming this week. I mean, we've copied some things over into config files, but that's, to me, a config file is not programming.
Yeah, but using Docker, Docker, YAML, all these new tools are part of what programming is today. And they're going towards this, lower code, no coding type situation. So even the programming that we all were taught and the, development of algorithms, all that stuff is out the window.
Yeah, and it's all about configuration and management of that. From my perspective, like when we talk about all the different kind of types of CIS, I mean, I teach sysadmin, we have networking here, we have programming here, we have We have a bunch of stuff. We have cybersecurity, like, so there's all these different, web development. We have, we have a cloud program that we're putting together, an AI program that we're putting together. We're looking at doing a DevOps program. Like, so there's like, when you tell somebody you work in computers, like, they assume you know everything. And that's, kind of that point that I make the other day. I'm not a web person. Like, that's one piece of this puzzle that I'm not very good at, but I am really good at building a network, right? And adding services to that, maintaining those services, managing those services. Like, that's a piece that a lot of folks just kind of think happens automatically. Like, and then as people talk about, well, everything's going to cloud, it's like, yeah, but cloud is a data center with physical devices that have to be plugged in, that somebody's got to be back there managing all that stuff. It doesn't just happen magically, right? On your end, if we've done our job right, then it looks magic. But there are, the rest of us, the ones that are in the back room, right? The man behind the curtain, the woman behind the curtain kind of thing. Like, we'll just be there doing our thing so that you think it's magic, right? And, and they just take it as normal now. Everything is like, everything that was amazing, 20 years ago is now just like, that's just normal, right? The fact that I can video chat with my granddaughter anytime I feel like it, like, that's just normal today. Like, but 20 years ago, that was what? Like, you would have had to spend, hundreds of thousands of dollars on a video conferencing system to make something like that happen. So I don't know. I agree with you. Like, a lot of the, those standards like the CSTA stuff is all, it's all based on kind of coding. It's not based on like the stuff that I do, which the stuff I do is what we've been playing with this week, which is making the services work, right? DNS and DHCP and, VPNs and, and web pages. I can, because there's a lot of stuff that goes into making a web page work, and right, everybody just assumes you can log into Weebly and and choose a template and you're done. Like, there's nothing, it's just, there's no, all the back end stuff they don't see that. So
no.
But Kathleen, what kind of platform would you suggest for us to start our own user group? I mean, why can't we do that here with this group of start with this group of people? I mean,
everybody has their own. Some people are, I'm doing some stuff with ACM, and they're doing, in their group, they're using Slack. I mean, some people do the Google Docs and, Teams and all that stuff. Teams is really popular today too. I'm not a big Microsoft or Google fan, but, I'm just concerned. I mean, I think it is something that long-term we have to worry about. I ran into this in the web, and computer science people who've never taken web classes are getting jobs, and we end up with sites that have tons of holes in them, and security people who've never done any networking classes. And it's just, I don't know, it's a big mess.
Yeah, how can you secure something you don't know anything about?
Right.
So what do? We have a master's degree program in security. They make an undergraduate degree in security, and they teach them just enough to give them just enough information.
Be dangerous.
Yeah, exactly.
Just enough to be dangerous.
So, and then cloud computing, it's not that intro course in cloud computing is just intro, but you need the networking to understand the cloud computing.
Mm-hmm.
So
yeah. And that's what, like, when we've been looking at this program that we're building, I'm like, we still need those fundamentals. I need them to know how a computer works, how a network works, right? We need to, if you're going to do cloud computing, like, you should probably know how a server functions, right? Those kind of things. Like, so those are part of that, build up. We do, we have upper level cloud courses where once you've got that and you've got the base understanding, then let's extend that out to a cloud environment, right? Where we can actually understand the security side of that. And, when you fire up a virtual machine, you know what we're actually doing versus just following instructions. Again, I'm not a big fan of just following instructions. I really kind of want them to dig into it. That's why you see me pull up files, web pages all the time, just like, here's additional docs, here's additional docs, here's additional docs. Like, let's look into this, let's build this. It's, I do a lot of Kahoots, and as I do Kahoot, quizzes with my students, especially when there's a question that everybody's kind of, is maybe half and half, or everybody got wrong, or like, I usually have the pages prompted already, and then I just drop them into chat, like, and then we can bring up the page and talk about like exactly what's going on with this particular question, kind of thing. So it's not just a matter of let's go through the questions. It's like, I want you to understand what's going on here. So you can't be good at this if you don't dig into the material. Like, I kind of feel like you can't be good at computing if you don't read. Maybe I'm wrong, but holy cow, I read a ton just to try to, keep ahead of everybody. So and I'm only like this much, right? Like that's about the like,
what do you mean keep ahead? Just like keep up.
Yeah. And I'm just trying to keep up. Yeah.
My mentors you're talking 1990s, her dissertation was on change at the speed of light, because as instructional faculty, we have so many things to keep up with, and it's not validated by other parts of the institutions ever.
Yeah. I mean,
Shakespeare is never going to write another piece of.
Right. I'm not an English teacher, right? Because, the English classes that I took in college 20 years ago, 30 years ago, they're the same today. like the only thing that may change is they may change the book that you read. Right? But the whole history. Well, history. I mean, unless it's current history, right? But if you're looking at World War II history or Civil War history, or like that is like that doesn't change a lot. So like we in IT, like if we just even look at the exam cycles, every 3 years we have to completely, like, they replace 30% of the exams every 3 years. So minimum every year I've got to relearn 10% of new content in every single class minimum, just to keep up with the exams. And that's not if there's any more like, technology that's introduced or like becomes a big deal. Like we have to kind of constantly work on learning those extra pieces. And
well, I teach 7 different courses, not sections, different courses. So I've got 7 preps every semester. And like you said, every 3 years, all of that stuff has to be redone. And my colleagues here don't get it whenever I say, you know what, I would love to come in and take part and be a part of this, but I really don't have time. Well, why not? Well, because I'm not just dumping some prefab content into my Canvas course. And oh yeah, by the way, you got to learn how to do all of that too, and think about accessibility and all of these other things that, so it's tough. But that's why things like this, where you can not reinvent the wheel, where, hey, look, I figured this out, and help get you started with stuff. That's why I've enjoyed this workshop so much this week, I think.
Good. I'm glad. Yeah. And I don't know. It's fun. I have a blast. I mean, I just seriously get paid to play, like, so I'm okay with that. So, but no, I just think, and I think if you can get these in front of your students, right, and do the things that we've done this week, like I don't know, if you take 20 students and throw them into a Cengage course or into a test out course, right? Yeah, they're going to learn the material and do their thing. But if I take 20 students and I put this in front of them, right, I'm looking at least a quarter, probably a third, maybe even a half of them that actually now are like, wow, I really want to learn this stuff, versus I survived test out or I survived Cengage, right? There's still going to be a group of students that are like, I survived, I barely survived.
Yeah, and I'm not saying that stuff is bad. I mean, I use it all the time in my courses, but it's just missing this part of it. Right. The engagement piece is really what it's missing.
Yeah. And for me, it can't be the only thing. I think that's the issue. I think for me, like canned curriculum like that becomes a crutch, right? I see my peers they completely rely on that material to do the teaching. They don't do any explanations. They don't do any kind of
what you're talking about is the application. When you say the application of math or the application of the theory that we're learning, that's what these projects are. And so project-based learning, I do really feel like it's the strongest way forward for our content area, because it connects a multisensory experience with the student. And when, the word engagement is based on an engaging activity. The content itself can be engaging, but an immersive application, like building some of the platforms that we built this week, that's really where you create this project. The project then has a longevity that exceeds the length of the class. I feel like projects that they see next week, next month, next year, they go, oh, I could pick that up again, or I'm more interested in continuing with this. That's the deeper design of projects, is it actually creates a more lifelong aspiration for the student. So that's why I just love projects, and I love this content development that you're doing here, Gary.
Yeah, excellent. Yeah, and I agree. I think that's, you guys, it should be obvious that, I mean, I'm all about having them like kind of dig into this stuff. And I do a lot of my work in the project form. I mean, early on, it's all about kind of just understanding basic information. But as I get them into, second semester, third, fourth semester type classes, this is the kind of content we do a lot, because I really want them to, to kind of flip over from, somebody else guiding their education to them wanting to be educated, and wanting to learn and wanting to grow and do those things. So
you are in
excellent.
Control of your own destiny. That's what I'm trying to tell them that.
I have that conversation almost every class. I can't do the work for you. I've already done this work. I can't do the work for you. I was like, I want you, you gotta put in the effort. Like, you gotta be excited about this. This summer I have my, it's a hardware class. Like, so this is the first part of the A+. We started with 30 students, and I looked at today, I'm down to 13 students. 17 students have given up on this class, like, just because there's so much material to be learned in a short 12-week period of time. It's like, actually, they only have about 10 weeks to learn everything. So I'm just devastated by the fact that that's happening, because we can't, I don't know. And I don't know if it's just, we're not in person. I don't know if it's because they don't understand the amount of material that has to be learned. This is after we broke the class into two. Like, it's still such a voluminous deal. So anyways, I'm and I got to find ways, and we get to a really engaging actually project this next week, where we take what we've learned hardware so far in this class, and then next week we're going to actually they have to put together spec sheets on several different types of computers, so they've got to do lots of research and things like. So it's a really fun, I've always found that to be a really fun, engaging project, and the folks that do the project really get a lot out of it. But it's like try to get them to this point, right? And if you lose, I've lost 17 out of 30 students. That's just an insane number. 60%. So, because of the content.
Part of it, I think, too, when you do these workshops, they're not really investing a lot of money into it. You know what I mean?
Right.
So that's different than the year-long workshops.
Right. Excellent. Okay. Are there any other comments? I mean, I know that now that we've got most everybody here, my goal this week, right? Right, as the resident drug pusher, is to have you hooked, right? I'm trying to, if you're not hooked at this point, I've got 2.5 hours to get you hooked, right? So, I'm hoping that I've done that. And, that was my number one goal, right, to expose you to all the different possibilities with this particular device, right? I think if Joe and I were talking early before most everybody was here, and Joe mentioned that a lot of folks look at the Raspberry Pi and they think toy, right? And I understand that a lot of people think it as of a toy because of its size and its its demeanor. But when you actually kind of dig into the stuff like we've done this week, you realize that it's super powerful. It can be the bridge for any student into this career, depending on how they engage with the actual device, right? And it's inexpensive, which is one of the big things for me. Like, I have students that don't have a lot of cash, and I'm competing for their entertainment dollar and their video game dollar, and I really need them to set that aside for the time frame that they're with me, so that they can then have a career where they can actually earn enough money to pay for whatever video game or console or toys that they want to. I don't have anything against toys, trust me. I like toys, but there's a point where you have to actually figure out how to actually be an adult and learn and, you know, and have a career and be able to earn your own income and, you know, not relying on other people. And a lot of my students are in that kind of place. Like right, you know, as a community college student, a lot of them are also in the place where you have a family and you already, you know, you have some kind of a job, you know, that maybe isn't a career type of a job, right? Working in retail or, well, there are some careers in retail, but it's not, you know, I've worked in retail. I'm like, you know, I just, you know, and they're trying to find a new way, like to do better by their family and things like that. And it's, you know, so we're struggling for their time. We're struggling for their, you know, for their investments, right? And I'm not trying to get them invest in me, but I'm trying to get them invest in themselves. I really like having this, you know, the device, you know, the Raspberry, you know, this thing that I can put in front of them for pretty low cost and like show them like the world of IT. Like, and again, I'm a system administrator by trade. I'm a system administrator. I am a generalist. I do a lot of things, and I try to share that with them. And you know, and I'll go down rabbit holes. If a student's interested in technology, I'll go down the rabbit hole with them just because I want to learn it. But then they see that pretty much anything they want to think about is possible, like from the technology standpoint, building 3D printers and you know, doing 3D design and all kinds of other stuff that's outside of our normal curriculum. But it's technology related. So you kind of find what they're passionate about, right? And put them on the right path. And that's always been my goal. I just want to get them on a path that they enjoy, that they can be passionate about. A lot of students come in and have an idea because they saw a chart that they can make money in computers, you know, and they can, you know, if I learn how to take care of computers, I can learn a bunch of money. And it's hard to explain to them that, you know, the people who make a bunch of money in computers are the people who really like computers and spend a lot of time learning about computers, not the people who just show up to class kind of a thing. So I'm trying to push this, you know, these ways for them to engage, right? To get excited about it. And I hope that you've seen that this week. That's kind of my hope, is that, you know, maybe you have a different perspective of what, you know, what this device can do and where you could maybe add it to a class. I'm not saying replace an entire class with this. I mean, I do those kind of things, but my goal would be like, you know, if I take any class, a cybersecurity class, is there one project we can do in this class where I could have them use a Raspberry Pi, right? And get engaged and have these websites that they have to dig into and they have to, you know, learn different pieces of the puzzle, to kind of get a sense of really what the real world of IT is about, right? Because what we've been doing this week is kind of the real world IT is like, I'm going to fire this up and I'm going to run through the instructions. And then I don't know what this is doing. Let me go look that up so I can figure out what I'm actually typing in here. And that's kind of how a lot of us have learned. And that's how a lot of IT is done, right? You know, a lot of students will say, well, Google's a technician's best friend. And it is, if you know how to ask the right questions and you have actually, you know, you read the documentation that you actually, you know, search for and find. So, so I don't know. I just,
Kerry.
Yes.
The other day you said that for your IoT class, the students need to buy the kit. It's part of it's like the lab fees, right?
Yep.
It's something. But
Instead
you only do
textbook.
that, yeah. But it's only in that class. It's not
Correct.
in all other classes.
Yeah. So at this point, that's it. So my goal, right? So I think where you may be heading with that comment or question is, I really want to get like, you know, so for our programs, right, there's another dozen instructors that are part of all these different programs that I've got. And so my goal over time is to get everybody on board with let's have CIS students when they sign up and take the first CIS course, right? That part of that course is the purchase of a Raspberry Pi. So part of joining the program, you have a Raspberry Pi, and then we let them know, hey, in these other 6 courses, there are assignments where you need this device. Like that's, you know, so then they keep this device kind of trailing throughout this, the set of curriculum. for me, like I know in my server class, right? Every student that's in there has at that point has taken my IoT class because it's part of our program, right? So I know they at least had the device within the last 6 months, and I can actually do projects around that. And if somebody doesn't have one, I've got enough in the lab that we can let them borrow one for a particular project. Or, right, if you wanted to try it out where you know, right now I have a lab set, so I can have other instructors try out projects using the lab set without requiring the students to buy a set. But I think the ultimate goal for me would be like, you know, and you come into the program, you do these things. I'm actually been working on a pilot program for for IT to, right now we have that standard. You have a semester, you take 1410, which is the hardware side of A+. You take that, you take an exam at the end, pass or fail of the exam, right? As long as you have a 71% in the class, you move on, right? So, and then you go to the next one and you do your thing and you have a 71 and you move on. And then, you know, the third semester they're showing up in my server class and I mentioned DNS and everybody has these big deer in the headlights. Like, what are you talking about DNS? Like, I'm like, we've covered it in this chapter, and this chapter in previous courses. Like, I can tell you exactly the page and the book number of where we talked about this topic, right? And you look at me like we've never talked about this topic. So one of my goals in this pilot program is we're going to put people into, it's not really I think we're calling it IT Jumpstart, something along those lines. But the idea is like, I'm going to get a set of students in the fall, right? I think we're going to do 20 students in the fall that are signing up for this program. And I'm going to mentor them through getting the ITF Plus, right? That instead of doing the digital literacy course that teaches Office and other things, we're going to do ITF specifically, take the test, and you have to pass the test to keep going. Like, so if you don't pass it, we're going to study what you didn't pass and you're going to take it again. Like, so you have to pass it. And then you're going to stay with me and you're going to move into into the A+ hardware side, the core 1 test. And I'm going to do the same process. I'm going to we're going to go through material. I'm going to have labs and quizzes and all these other things that you would do, but it's kind of, you know, you have to get to the point where you can pass the exam. So if you don't pass it the first time, you don't just move on to the next class. We're going to figure out what you didn't know. We're going to teach you that, and then you're going to take that test. So it's like, it's not credit for prior learning, but it's a competency based, right? And our levels are, you have to pass ITF, you have to pass the core 1, you have to pass the core 2. And at that point, once you've done that, then we're going to release you into whatever program you're doing. But we know that you've at least spent the time on the fundamentals. Like, we don't have a whole lot of, we're still going to have gaps, but we're going to have a lot fewer gaps. And my 2 things that I'm hoping to get out of this, first of all, I'm trying to build their confidence in taking and passing and being successful in IT by passing these exams. And I think, you know, future success. Like, I think they'll be more successful in the next courses because they've gone through this process and had a mentor that was dedicated to helping them be successful in these things, instead of going, okay, you got a 71, great, go on, right, knock yourself out. I always use the example of, right, build me a 71% computer and let me know if you think I'm going to pay you for that, right? Or build me a 71% network and see if you have a job next week. Like, so there's this, I don't know, to me, there's this disconnect between, you know, school grades and like the reality of our situation. Like, in IT, you can't do 71%. You can't even do 81%, right? An 81% computer is not a functional computer. An 81% network is not a functional network. So that's my mentality about all of this. I really, like, I expect them to kind of go that direction. And the ones that do that take that advice and kind of join in with that thinking are the ones that are the most successful in our program. They're the ones that get the really nice jobs when they get out of school. They're the ones that have good pay, and then they're emailing me, you know, months and years later about the new job that they got, and, you know, sending me a picture of their brand new car that they were able to purchase because they have this really sweet job, and, you know, because they did really well, because I pushed them to get these certs or do this or do that later, you know, earlier on. So I don't know. I know we're just kind of talking about kind of my philosophy and things, but thanks for joining me this week. I hope, like I said, I hope that you've gotten value out of this whole week. It looks like Kathleen's already started with our professional learning development community. so keep a look, you know, keep an eye out on the chat there. Raspberry Pi.University. That's pretty cool. I like that. Nice. Yeah, good. All right, so keep an eye on that. We are down to the point where we, I think we were going to try to do the VPN, right? That's kind of the goal today, unless somebody has a major headache with that. But it seems like that was the last little, like, most interesting thing that people were going to try. So if you've done this last week, we did the Openvpn one. We're going to do the WireGuard version this week. So it'll be slightly different. I think a lot of the commands are the same up to that point. You know, so if you want to do something different, if you've already done that last week and you want to try something different, you're welcome to, you know, kind of grab one of these tutorials and kind of continue working on as we go through this. But yeah, I think we should do that. The VPN. The problem with the VPN, it's not really a problem. Or did we run into this last week? Did it work last week with wireless, or did we have to have an Ethernet connection? I think as long as we're on the same network, it should work, I believe. The one thing we do need to have, and I think this is one thing we did figure out last week, you do need to kind of have your own DNS internally. So we'd have to actually set up DNS on your VPN router before we get started, right? So I think that's the kind of it's a two-step process. We have to have DNS, domain name services. Otherwise, the IP address that we get assigned to get to our VPN is it's a public address, which won't work for us. So what you really need is from, like, if you're on a computer, right, on this Zoom call, you need to have your Raspberry Pi, right, connected, and they need to both be on the same network. So, like, same things that we've been doing where we can VNC or SSH to the device. Either one I think is going to work fine in this situation. And if you have the ability to make a network, like have a second network interface or something along those lines, like I have those Ethernet adapter, USB to Ethernet adapter. We can set this up and we can connect to it, but if you don't have a network behind that particular device, then we won't be able to actually do anything on the other device to kind of test that you have it. We'll install an a client on your computer, and you'll connect to this device. That's the only way this works. So knowing that, right, knowing that we need, the best way to do this would be to have your Raspberry and your computer on the same network, right? And I think wireless or wired is going to be fine. And then using either wireless or wired network on the other end, if you have another device that you can connect on a different subnet, then that's the best solution, right? That way, then we can test, like we can ping all the way out to the other device and test and make sure that it works and is functional, and we're getting IP addresses and all that kind of fun stuff. Otherwise, we could also just have the VPN server on the Raspberry on our network, and we can connect to it and we can see that we're connected. But at that point, that's the end of the demonstration, right? Because it really isn't anything else for us to connect after that. Okay. And that works perfectly fine too. Just understand that, like, full functionality would require us to have other things outside of that network. Okay. So we'll go with that. what you should have then is we had kind of left it at the end of the day yesterday. You should have a clean installation of a Raspbian. So one of your SD cards overwritten. It should have been overwritten and then updated so that you can start. We don't have anything in the way, right? And then I think what we'll do, and I'll do what we'll do at this point. Like I think this is it's a good place for me to go grab a coffee, but make sure that you have it set up that you VNC, right? So based on what we did earlier this week, that you've connected with VNC or SSH to this device. And once that's done, then we will get rolling. I have mine connected in the background here. I haven't shared my screen yet, but I have mine connected in the background, and we'll get going. We're going to set up DNS first. So and its DNS is a relatively simple install. We'll need to make a change to get it functioning the way we want it before we get started with the VPN setup. Okay, so let's do this. Let me do like 5 minutes. I'm going to go brew a cup of coffee real fast. That way you can get yourself situated. What we want to have when I get back is you're remotely connected to a clean installation of your Raspberry. And then we will get rolling with DNS first, then a VPN server. We'll set up a VPN client on your computer, and we'll connect your computer to your VPN server. Okay. And then that'll be wrapping up the week. That'll be a networking component. There's a lot of stuff in the networking side. Like we did a whole class on networking last week. So you could teach like every component. I teach a Network Plus class where I have the students build an entire network infrastructure using Raspberry Pis so that they actually learn the content that we're actually reading about in the textbook. All right. So I'm going to pause, go get a coffee, get your machine set up. When I get back in 5 minutes, we will get started.
So I set up my Pi wallpaper for this because I think it reminds me of Carrie. I thought that was cute.
That's adorable.
I think that should be his avatar. What do y'all think?
Oh, absolutely.
See you guys back in a bit.
All right.
So so here, this is the Raspberry here. Last week we built this Pi hole. This is a DNS server that's also a ad blocker, right? So you can see of the traffic on my internet connection, 12.3% of my traffic is blocked as ads. So lots of stuff going on, but I'm using this. We'll use this for DNS settings later on. We are going to set up a DNS server first thing. So we should do it this way. Set that here. That's going to be let me move the cameras over. Let me open up the chat so I can see what's going on there. If we do have time to make a wireless access point at the end, we'll do that. The wireless access points it's a fun project too. It's there's so many ones that are fun. It's like, it's hard to pick them, but so trying to pick the projects that the project that we had that would kind of expose you to like the greatest number of like potential things that you could do in your classroom, and you can kind of see, you know, the expansiveness of what's possible. I think that's what the choices of the projects that we did. And then obviously like web admin yesterday was just, Carrie wanting, being interested in that, that particular setup, right? And I think I really liked it a lot. I'm still thinking about that. I'm like, I want to put it on the computer that we're looking at, right? Just so I have that there and I know what's going on. And but yeah, the Pi hole is really cool. You kind of get funny looks when you say it, right? But it literally, like, it's an ad blocking utility. If I didn't have it, this website, the Pi My Life Up website, there would be ads along the right hand side, and then about every like in between each of these little pieces, there's another ad that comes up, and you know, so it's, if you go out to the web pages, you're probably seeing ads unless you have something like that in place. I'm putting the DNS server link into the chat. So for this, we need to set up DNS server so that we have a local DNS server to point to. I'm going to walk through this. I'm going to put this on the device that is also the VPN server. And we'll just point the VPN server to itself when we get to that point in the process. Okay. We're going to want to set up a record for that device so that when we say go to this DNS to get the record's there, kind of a deal. All right. So we're going to do that first. I am going to leave I'm going to leave my DNS set to the Pi hole that I've got set up, but we will set up a record. We're going to go through the process as if you guys were doing the process instead of my machine following that. I'm trying to make sure I clarify that. Like, I'm going to leave mine as is. We are going to set it up so that you can have this operational on your own without having to do anything on other machines. Okay. So on this machine, the first thing I do want to do on this machine, I want to go, because this is a brand new machine and most of you probably have brand new machines, right? Or you've got a machine that you've had for a little, you know, and I want to change this, right? So I'm going to call this VPN. I will just call this VPN server, right? And that's going to require me to reboot. Okay. So I'm gonna go ahead and make that change real quick, reboot it. It should fire back up and then come back up. At that point, then now I can put a record in for VPN server in my DNS that is different than the typical Raspberry Pi name, right? Because like I said, right now I don't know, probably 2 or 3 different Raspberry Pis on the network that are called Raspberry Pi. So I don't want there to be any confusion around that. So I can see that my machine's booted up on the right-hand side. So as soon as VNC gets rolling, it should reconnect. So there we go. Reconnected here. All right. So then off we go. So setting up the DNS server, sudo apt-get update, sudo apt-get upgrade. I just installed this. I just did the updates, so I'm going to skip that piece. We are, though, going to load the update so that it has the latest pieces, the latest list, so that if we need it later on, which we will do in the next command, right? We need to get DNS mask, so we want to make sure it has the latest copy of whatever that file is going to be. Okay. So the next one is we're going to install a program called DNS Mask, which is a DNS. It's a lightweight DNS server that you'll see in quite a few tutorials that are Raspberry Pi based tutorials. I think even we use DNS Mask if you do the access point as well. So it looks like almost a meg of stuff that needs to be put in. So we get this install done. Okay, so sudo apt install, like the same kind of process. I mean, I think one of the things, this is a really good device to use if you just want to teach Linux, right? Because it's Linux, and you could just do the whole class in this particular device. Have them do all of the, they can do everything that you can do on a regular Linux machine, and they could actually build it out and build these extra devices into their system. Okay. So that looks like that installed. So I just kind of don't see any errors or anything like that. That's nice. There is a sudo, I got the whole, this is a brand new machine, so color 0 is still in there, but we'll leave that for now. I'm not going to mess with that one today. All right. So then what we want to do then is we need to go into the configuration file for DNS Mask and make some changes to actually turn on the DNS server, right? To actually to make it a live deal. So we'll do this with the sudo nano /etc /Dns Mask.conf command. Here we're in step 1 on configuring the DNS server. So the link to this is in the chat. So this is going to get us into the DNS file, the DNS mask configuration file. It says right here you can use Control-W to search things, but you can see domain needed is on my screen. It's right here on the bottom of the first page. So I'm fine just kind of going. Oops, I went right past it. That was awesome. Here it is right there, right? So we need to uncomment out this, right? So never forward plain text without the dot or domain part. So we're going to say you have to have it, right? Domain needed. This option of the server does not forward names that do not contain a dot, right? So if you have .com, it'll forward. But if you just have like, in my case, VPN server, that will not forward that request onto any other DNS servers, right? So it's not going to do the recursive lookup or the iterative lookup if you have this line uncommented out, right? So if it's an active line in the configuration. Otherwise, if you were to kind of search to say for VPN server and it didn't find it in its local database, it would start asking Google to find VPN server without the .com, without those kind of things. So does that make sense? I'm hoping that makes sense. That's kind of the idea of this command. The next thing we're going to look for is this bogus-priv command. So we're going to go. It's right below it, right? So never forward addresses in the non-routed address space, okay? So I'm going to take that one out as well. This one means it's not going to forward reverse lookup, right? So if I have the IP address and I'm looking for the name, right? That's a reverse lookup. It's not going to forward those either. So this will keep all of our private stuff private stuff. The next line that we need to find and uncomment is the no resolve. And what this is telling the computer is don't use the resolve file for upstream name servers. Okay, so we're just going to basically resolve file. There should be a no resolve. I'm just scrolling down. There it is right there. Okay. So no resolve here. If you don't want DNS Mask to read the resolve.conf or any other file, getting its servers from this file instead, right? So what we're going to tell it to do is don't read the outside file. We're going to give you the servers here in a minute, right? So the next thing we're going to look for, and it's a little bit lower on the list here. It's right here. Add other name servers here. So what we're going to tell the computer is, and I'm going to enter in right below this. We're going to enter in server equals 8.8.8.8 and server equals 8.4.4.4, 8.8.4.4. These are both DNS servers from Google. You can use quad ones. You could use I think quad fours is IBM. Quad ones is that Cloudflare? Quad ones. I can't remember. I think it's Cloudflare. But these are the most common ones, right? And if you're going to do DNS lookup, like who's going to have a better DNS lookup than Google? Not a whole lot of people because so many people use it. So we're going to tell our server, hey, if you can't answer the question, if you can't answer the DNS query, and it has a dot something on it, and it's not a reverse lookup, then use one of these two servers, right? Use these servers in this order to ask those questions, okay? And it also it kind of points you out here. You can use other public ones. So I'm just curious, right? Cloudflare 1.1, right? And then OpenDNS is, I don't even know which one the OpenDNS is. It doesn't give you the listing here. So you could probably track down where it's at, and I don't know the numbers. I was hoping that it would just give us the numbers. But you don't have to use, right? You don't have to use Google's numbers. These are just really simple to use. They're easy, right? You can do one-to-ones. And I think quad fours belongs to IBM. So if you like IBM better than Google, I didn't go that route. Cloudflare, I believe, if I'm not mistaken, and somebody can correct me if I'm wrong. I think Cloudflare is they mask your queries. I think they do. I think they require you to use the like a hash. We'll see. All right. The next thing we want to do is we want to tell the server that we want to cache more items than the default set, right? And it doesn't right now. The default set, there isn't a cache in our server right now because we haven't turned on the cache. We're going to turn on the cache and tell it, hey, keep 1,000 records, right? I think instead of 150 records. Not that we're going to ever, get there with this particular system. I may have to look that one up. So I'm going to do a Control W and look for # cache. And you can see that my cursor went right to where I need to be. So I'm going to uncomment that out, and I'm going to change the size to 1,000, right? So this particular record, or this particular command is telling me how big to make the cache, right? And I don't know if that's in record numbers or if it's in like some kind of a megabyte or kilobyte. I want to say it's in the number of records. So the other thing that now, right, comes to mind is DNS Mask Documentation. Actually, DNS Mask.conf documentation is really what I'm interested in, right? Because we're dealing with the .conf file, right? So this is GitHub for DNS Mask. So I wonder, do they just have the listing of it? I don't know if they have any explanations of it. Wow, that's a lot of stuff. It's a big file. So you can do lots of things. It doesn't look like what the, wonder. So if I go up one level, right? If I go up one level, then this is mirror of an upstream. So this is not even, let's go back. Man page for DNS Mask. So this will be interesting, right? So this one will be interesting, right? Again, as we dig into what is all these other things doing, we're only going to follow whatever it's telling us, which that's not really what we want the students to be thinking of. So this is Debian and kind of their basic DHCP. So this one's probably good. Local caching, things like that. There's going to be some information here. And this is based on Debian, which is what Raspberry Pi OS is based on Debian. So this is would be a really good article for this particular project. All right. So I'm gonna go back to, I just wanted to make sure we had some outside documentation that then supports what the things that we're doing here. All right. So once we've set the cache size, we're going to Control X, right? Y. Oops. I should be on the actual page itself. Control X and Y. Enter. So we've made the changes, which would then turn this into a DNS server. In order to make it work, we've got to sudo system control systemctl restart DNS mask, right? So at that point, because we've installed it and it was running, and now we've made configuration changes, we want to restart this. And now we have a DNS server that should be up and running. We can verify that it's up and running by coming in and doing sudo systemctl status. Oops, I should spell status correctly. DNS mask. And you can see, right, so here's the command that I typed in right there, and we see active running right here in bright green. That indicates to us that this service is running, right? And it's running using the code that we just configured. So we have a DNS server up and running, okay? So testing the Raspberry Pi DNS server. So in order to do this, right, we're gonna do some testing, right? So, which is right up my alley. I like to make sure that we have, like, Yes, it's running, but is it working, right? Let's see if it's working. To do this, we're going to use a tool called dig. In order to do that, though, we need to install DNS Utils, which includes the command dig. So we're going to do sudo apt install DNS Utils. I think, to me, this one is one of those ones, and I'm going to write this down so I don't forget this. But like when you're doing a basic, you're doing a basic installation on a Raspberry Pi, right? So you normally do the install, then you do like updates, right? To me, I'm thinking, hey, you know what? We should probably put web admin on the machine so we can kind of have some insight into the computer. Maybe part of the installation becomes, let's install DNS Utils, because then we have that, that pile of tools available to us, right? There'll be a preset of things that I think that we should probably install as part of a normal installation. And I think DNS Utils is probably one of those, right? We can get access to the tools to help us figure out troubleshoot networking issues. Okay, so I'm gonna go ahead and install this real quick. Off it goes. And then now I'm curious, right? So DNS Utils, documentation. Let's see if this, we can go back. There, I saw a Debian one. And we're in Buster. All right, so this is the package. Does it have... I'm curious. I'm like, this one, like if there's other, like, does it explain other things, like what you can do with it? This is kind of what's there. Some basic information. Looks like it's kind of like it's only giving us dig. The whole thing is giving us dig. Well, look, there's other things. I guess bind, some other stuff that's doing. I'm going to put that down. I want to look up some more documentation. I don't want to take up your time trying to find that information. All right, so it looks like the install is done on the left-hand side here. So we've got DNS Utils installed, and at that point we can run this command. So we're going to use the dig command to look up Pi My Life Up, and we're going to redirect that command to the local host, right? So we're going to tell it, hey, use the DNS server that's on the local host for this purpose. Okay. And when we do that, we get the response, like this is a response here. And what we want to see is down here, the server. Okay. This server is responding, instead of responding like the example over here is it responds with 127.0.0.0, because IP version 6 is running, it's going to respond with the IP version 6 version of the same exact thing. So in IP6::1 is the local host versus 127.0.0.1, which is IP version 4. Right. So this is telling us that it got the information. Here are the IP addresses for Pi My Life Up, and the local server. Right, the DNS server that's local did this. So we know that our lookup query worked properly by running it that way. Okay, now you see that the query time took 73 milliseconds. Okay, if we run that command a second time, and I look at the data down here at the very bottom, now it's 0 milliseconds. Right, I'm on the machine. The first time I ran it, the machine had to go out to the internet to 8.8.8 to get the answer. And when it got the answer, it cached the answer, because we have that cache equals 1,000, like we built a cache. And now it takes no time. Like literally it can respond immediately because the information is stored in the local cache, right? So this is showing you that that's functioning. and that it's properly caching the information like we want it to be. Okay. So the server's set up, the server's functioning, DNS is set up and functioning, right? And again, that's a super basics install. If you wanted to add records, right? So we do want to add records to this. And we'll need to go add a record here. So I'm going to bring up my DNS server just to look at the local DNS for what we did last week for DNS records. And last week I did RASP-3, which was the computer that was the VPN server that I built last week. And we're using .local, right? So that it's on the local network, and then we have to give it an address, okay? So in order to do that, we need to, on the DNS record here, I want to, on the DNS server, I want to give it I want to put a record in DNS specifically for this server that we're on, right? So the Raspberry Pi server that we're running, which I call VPN server, okay? So we're going to make a record for VPN server .local, right? And this one, this is on, I'm connected to, let's look how I'm connected. I don't remember. So so I'm going to go with ETH0, which is going to be 172.17.69.133. Okay, so that's my ETH0, which is the Ethernet adapter that's on the computer. If you're connected with Wi-Fi, you would look up the Wi-Fi number there. But we need to associate the IP address, like the inbound IP address for whatever network you want it to be on, right? In fact, I probably should, and I will for now. I'm going to unplug my second Ethernet there because I don't have it separated out onto a different network at this point. Okay, so it's departed. That's funny. It left. I don't know what happened. I just saw, okay. So if Angelina, if you're still here, I got it. No worries. Cool. So that's the plan. Like I need to create a record for that, right? So to do that, we are going to sync these up again. We need to edit the host file, right? So sudo nano /etc/host. I think it's a host with an S. We'll go back and double check my instructions that I did earlier. Hosts, yeah. Okay. So sudo space nano space /etc/host. That's the local cache. Should be. Right. This is going to be the local settings that I can tell. Like so right here, like if I don't want, like I almost want to get rid of these things, right? So that it's all IP version 4. But for this server, right, you can actually see I already have a record in there, 127.0.0.1 for VPN. Localhost is fine. What I'm thinking I want to do here is I would like to make this the IP address of this box instead of the local, right? So I want to change this record. I'm going to change this record and see if I think this is going to work the way I want to. 172.17.69.133. Okay. So localhost is still 127. So if I'm on the machine, I do localhost, it's going to be 127. If I direct my computer to this as the DNS record, right, my DNS server, then it will return this IP address, which is the network IP address of VPN server. That's what I'm looking for. Okay. So I've made that change in the etc host file to point to this server. Okay. I'm going to control X. I'm going to hit Y, and then I'm going to hit enter to save that file. All right. I'm also going to go, right, because my machine is pointing to Pi-hole for this. I'm going to go and add a record. Oh, I've got to go up here to do that. So add a domain, right? So in this case, I'm going to do VPN server, and I'm just going to do .local again. And then the associated IP address is 172.17.69.133. Okay, so I'm adding this to my entries down here. So VPN server.local, I've got the new address. I can delete Raspberry 3 from this because it's no longer, I'm using the same box. But I want it to point to VPN server because that's the name of the device. Okay, so I updated the DNS record that my machine is looking forward or looking to. What you could do at this point, right, especially if you tested earlier and DNS worked, right, you're going to want to change your DNS settings on your PC or laptop to point to your Raspberry Pi based DNS, right? So if you, and this may be, if you're in a computer lab somewhere and you don't have access to IPs, you may have a problem. Now that we got there, like if you're at home, you probably have control of this. Right. So in this case, I would go to my computer. Right. Oh, man, I hate the way they do this now. Change adapter settings. Like, I don't know why you can't just go to properties. Right. And if I go to my IP version 4 and go to properties, you can see that I'm getting my IP address automatically, and I set down here, I'm setting my IP addresses manually. So you're going to want to set your IP to go to, right, that local DNS server. So in my case, I would change this number from 143 to 133, and that redirects it to my Raspberry Pi DNS, which if you've tested it, you know functions. So you're not going to lose connectivity, but you're going to be getting the records from this. So it'll give you the proper record. I'm hoping that makes sense. No, this website on the right is not that. This is my computer specifically. You're not going to see this. Right. So you should see, like, you have this piece here, right, which is this is your VPN server, and we set up DNS on it, right, and we tested it. That's what this testing is all about, to make sure that that DNS server was working. And then you need to go on your IPs. You need to point it to your DNS, the new DNS server. And this can be temporary. So if you have something in these boxes, write them down, because you're going to put them back after we're done with this. Okay, because as soon as you turn off the DNS server later on, when you're tearing everything apart, if you don't change this back, then it's not gonna function. So on your properties on your computer, you need to set the IP, the server, right? And if you want to, if you put this first one as the Raspberry Pi that you just set up DNS on, right? Let me go back and do this. This is my server that I just set up DNS on. I went to the IP addresses to figure that out. Like, that's my address. The other thing that I could do, right? You remember host name -I. That's going to give me the IP address as well. That's the address that you're going to want to put in your DNS settings on your computer that we're going to connect to the VPN, which should be this particular box. You shouldn't lose connectivity if you've tested it and it replied back with the Pi up stuff, right? So if you did this testing here and you got responses, right? If you got the responses like we have right here, then your DNS server is functioning the way it's supposed to function. So you won't lose connectivity. Make that change. You can also put 8.8.8.8 here as the alternative, so that if for some reason you turn off that DNS server, then it will automatically use, an online DNS server, so you won't lose connectivity to online, to the internet kind of components. You may have, if you have local DNS servers, then that you may want to replace that alternate with your local. So I do have, like, this one is a separate server on my network. Actually, that's the wireless X. I don't think that one's functioning anymore. So I would put my alternate, in this case, my alternate is going to be my router, right? So I've got my primary DNS server, which is the Pi hole, and then I've got my secondary DNS server, which is the actual router on my network. Okay. That way then, if something happens to the Pi hole, then I would be able to continue to connect to the internet, but I wouldn't have ad blocking any longer. And we didn't set up a Pi hole for you guys, so if you don't have one, just ignore that part of it. All right, so I'm hoping that that made sense, that you've readjusted your DNS server or your DNS settings to point to the current DNS server, and that you've gone you've done the sudo nano etc host, and you've gone in and you've added the name of your VPN server with the IP address that you got here from the hostname -i command. Okay, that part's not on that part is not part of the tutorial. It is something though that you want to have set before we start the VPN tutorial. Yes. So when you say on the computer, you're talking about on the PC, or you're talking about on the Raspberry Pi? PC. All right. So from the PC, I just went down to networking, right? And if you click right mouse or left mouse, you get this network and internet settings option. So that's a left mouse click, you get this. If you right mouse click, you get troubleshoot and then open. So open networking internet settings. From here, I click on Ethernet, and then on the right-hand side of my screen, I've got change adapter options. Sometimes it's over here. It kind of moves around on me. Right now it's over here. So change adapter options is what I'm looking for. That gets me to what used to be the network and internet. This is what we used to go to, like immediately. We didn't have to go through any of these other menus. And then I'm looking for the Ethernet adapter that I have currently connected to the network. So I know like these are unplugged. This one's a virtual. So I'm not worried about these pieces. I am worried about the one that is live. That's this one here. That's my current IP or my current interface for my network. I'm going to right mouse click on that to get to properties. Right, I get a contextual menu of things I can do to this item. I'm going to go to properties. In the properties box for Ethernet, my Ethernet adapter, I'm going to go to IP version 4. And then I've highlighted IP version 4, and I'm going to click on properties. That will get me to the configuration page. Normally, you're going to have obtain IP address automatically and obtain DNS servers automatically. Right? For this configuration, we want to point our PC to a different DNS server than is normal for us. So we're going to use the following DNS server address. So you're going to click on that radial button, and then you're going to type in whatever IP address you got from the host name command on your VPN box.
Okay.
Right.
I figured out my problem. My computer wasn't connected with the Ethernet. I was going over wireless.
Oh, there you go. So yeah, you were going to change the wireless setting then instead of the Ethernet setting.
I don't want to do that.
Okay. No worries.
Thank you.
So then it may not work then. So be aware of that.
Well, I actually got the Ethernet adapter, so I'm going to
Okay, there you go.
try that.
Yeah, plug that in and roll from there. Okay. All right.
Thank you.
No worries.
I put it in the chat room. I don't want to screw it up. My VPN server in my host file is changed, but if you run dig on VPN server, it still shows my 127.0.1.1. So do we flush it out? How do we?
No, because if you're on this machine and doing dig, it is the local host that's going to respond, so it's fine. That's not a problem.
The response of the IP address in the answer section is still pointing to the 127.0.1.1. That's okay.
Yes, right down here you're talking about. Yeah, that's fine because it is local. It is your local host that's responding.
Okay.
We want that record with the IP address so that another computer, when it goes and looks for VPN server, it's going to get that local address, not the 127 number. It's going to get a real IP address to go to. Otherwise, the VPN would hand it 127.0.0.1, which is then going to point at itself, not the VPN server. But if you're on the VPN server and you're doing dig, then your local host is what replies. So that's why it replies that way. Okay, that part is done. So let's go and take a look at setting up the VPN server. We are going to use the instructions for WireGuard, which is the newer version of It's supposed to replace the Openvpn, which is an open source VPN server. And we did that VPN server last week. It looks like the instructions are essentially the same, except for one point where you choose WireGuard instead of Openvpn, I believe. I don't know that there's a whole lot different in this set of instructions. Okay, so I'm going to share that into the chat. So you have the instructions for that one over there. And if you've hopefully, you've been able to modify, and I know some of you may be like in a classroom environment or an office environment where you don't have access to change your DNS settings. So then at that point it becomes an issue, which is, I think we talked about that as part of a potential problem yesterday with try to do through this process. So if you're going to build these in-house, like you're going to have your students build these in-house, and you may want to have like a switch, and you want to connect computers and devices on a network where you can control the settings of the machines. Okay, so in an environment where you don't control the settings, the network settings, and you can't modify them, then like a project like this becomes really difficult to actually pull off. Okay, cool. So let's take a look at this. I'm sure the first thing we need to do is update, right? We're not going to do that.
So Carrie,
yes,
I was able to. I'm able to make all the changes and everything, but now I don't have any intern. I can't resolve the address to Pi Up My Live
from your PC.
From my PC, yeah.
And the PC that you're using, is it the same one you're on the Zoom call on?
Yeah, which is odd.
That is. And it resolved when you were on the local host?
Let me go back and check here. Hold on. I mean, it did, yeah, whenever.
Okay. Right.
That is strange. Hold on. Let me do it again. Yeah, it's resolving still.
Okay.
That's weird. I can get it on my Pi, but I can't get it on my PC either. It says DNS probe finish bad config.
Yeah, that's what mine says too.
Yeah.
Really? Okay. But we haven't that's weird.
Yeah, I can't even get Google.
Okay.
Yeah, it also, whenever I made those changes to point to the DNS server, the that we set up on the Pi, it dropped my email also.
Okay, so we got, so there's some resolution issues then. There's something, which is weird, because if it can connect, if it can resolve it, then we know DNS was functioning, and we know that DNS is sending a request out, and it didn't, your DNS request wasn't blocked.
So, I mean, I wonder if it is because...
Did you do a secondary? Because I just added in a secondary IP and it worked.
Yeah, if you get a secondary, then it will... Yeah, if the first one can't resolve it, the second one takes over.
Right.
So we want that first one to resolve a local number. So, yeah. So at this point, I think maybe just on yours, make sure you have a secondary pointing to maybe to Google, or if you have a local internal one that you have to use, that's fine too. We don't really need. Well, for your, at this point, you haven't been disconnected, so you still have some kind of, we still are
resolution
okay there.
going on, yeah.
Yeah. All right. So yeah, running that second one. So that's what we're talking about. I'm trying to make sure everybody's on the same page. Is on the network settings, change adapter options, right? So I don't know if you notice on mine, I have this is my Raspberry Pi based DNS, and then I've got my router as a secondary. So that if something happens here, that this one then would resolve for me. So a second one here will maintain just this weirdness that we're seeing.
Yeah, that's how it's designed. I didn't put one in initially because I thought, well, okay, we've got it. So yeah, I mean that does fix it. Yeah,
it should have, and that's so. I mean, we can. I mean, that's one of those that's a path that we can kind of go down. I think we're probably not, because I really want to kind of finish the idea of getting this finished, and then but that would be something that you'd want to track. Why is that not functioning? Because it should function. It functions right here. It functions exactly the way it's supposed to function. So if I point to it, it should function. It should do what it's supposed to do. So I wonder if it has to do with us changing that IP address and not having it, but that shouldn't be it. I don't know. Well, again, I think that's a rabbit hole we could go down. I don't think we should right now, in order to make sure that we actually end on time today.
Onward and upward.
So we need to make sure that curl has been installed. So curl is a way for us to go get packages. So this is the sudo apt install curl-y is the installation for that. And the -y, I think we've seen this a couple times this week, is the -y just automatically answers yes to the, do you want to install this? And you can see on my machine, curl was already there, right? So, and this is one of those, just making sure you have that, more than anything else. Okay. And then in order to install this, now we're going to use the curl command to run an installation of Pi Vpn, okay, which is the software that will install either WireGuard or Openvpn on your device. Okay, and it's going to push this this script out to bash so that it runs the installation process. It's essentially what this command is doing. Now this is another place where we could bring up documentation on what curl does and how it works, and explain it, and have them go through it, or at least have documentation about specifically this the command that we're running. But this is going to basically, it's running a script at this point. They're going to fire off the installation script, installing packages that it needs, and then I'm going to just start scrolling over here on the right hand side, right? And then we're going to go through, right, a text-driven menu system to do the installation, right? So they've built a little text-driven menu installation. So this installer will transform your Raspberry Pi into an Openvpn or a WireGuard server, right? So we're going to do WireGuard. So you just simply hit enter on the OK button. Okay. The VPN server is a server, so it needs a static IP address to function properly. Okay. I think in the previous example, we left it as DHCP, because we're gonna fire it up, we're gonna test it, and then we're gonna not use it anymore, right? So if you were gonna make it a permanent thing, then you'd want to make sure that you assign a DHCP or a static IP address, and that if you have a DHCP server on the network, which I do, you'd have to go and put a reservation for that particular device, right? So again, that's a piece that we could run into, and you can add into this particular topic. Because I don't control everybody's networks, and we don't have a kind of a common thing, I don't want to mess with that. I'm just going to leave it as DHCP. Okay. And then so yes, if you choose yes, you keep using the DHCP reservation. If you click no, it's going to try to convert that to a static, right? Which then could cause, duplicate IP problems if DHCP hands that address out again. Okay, so I'm going to go yes, right? So that it keeps the DHCP resolution or addressing. Okay. So choose a local user to hold your OVPN configurations. Okay. I need to scroll down over here. We're going to click OK. He wants us to choose no. We're going to choose yes. I'm not worried about step 4. And then I think step 5 is also part of the network. And now we're on to step 6, right? So by choosing yes, we skipped over like 4, 5, and 6. Or we did 4, 5, and 6 all at one time. So I'm going to click OK. There's only one user available, right? So then this is going to be a tab to get to the OK button, right? You can see that there's an asterisk here in your Pi as the user. So that's choosing Pi as the user. You have to tab to get down to the OK. And I'm going to click enter to run that command. Okay. And then finally, we're going to select the VPN software that we want to install. For us, we're going to choose WireGuard. Okay, so you can see that it's selected already, the red there. I'm going to hit tab to get to the OK button. If you hit a space, it will undo WireGuard, and then you hit a space on, you can up and down to go to VPN, and you can do each of those. Okay, I'm going to click OK. I tab to click OK to choose WireGuard. Right, the screen allows you. All right, so it's cruising through. All right, so this is the default port that WireGuard uses. I'm going to write it down just so I remember it. 51820. I don't. Yeah, we just need to tab to OK and hit enter. And then it verifies, is this setting correct? Yes, it is. So hit enter. And then now we're going to specify the DNS provider. And I believe, if I'm not mistaken, so this is where we're going to jump, not following the process here. So Pi Vpn is local DNS. I think that's what we want. Last time we did custom and pointed it to ourselves, I think, is that for everybody that was on the call last week or on the, I think we did custom and pointed it to ourselves, right? Or pointed it to our device. I'm curious, like in the case of the local resolver, I unbound, select Pi, make sure the resolver is listening on 10.6. I'm going to go with custom. So you see, it took the little red square and I put it on custom. I hit the space bar to select custom. And then I'm going to tab to OK. So this is where we're not following the instructions. 11, we're not following those instructions exactly. Okay. I chose custom. And I tab to get to the OK, and I'm going to hit OK. Okay. And then the desired upstream, I believe. I'm looking to see if there's, oh wait, no, those pieces don't go. We need to come up, we've got off track here. So the desired upstream DNS server, I believe here we put in 172. We put in our address for our DNS server.
On that previous step, why would you not pick Pi VPN is local DNS? Why would you pick custom over that?
Because the Pi, there was, shoot, without going, I don't know how I don't think we can go back. There was.
In the directions, it'll say if you have a local resolver running, unbound, select that one and make sure your resolver is listening on 10.6.01. I don't know.
Right. So, and that's the part that scared me, because we're not using 10.0.6, that network. We're not using that network. So
okay, so got it. All right.
So I didn't want to have it force a particular IP structure that we're not functioning on.
Okay.
So that was my concern. And I think here we tell it, hey, I want you to look at my DNS server to get all your resolution.
Got it. Thanks.
I'm like 90% sure this is how we did this last week. So like I said, I'm never 100. It's like, I swear I did. This is how we did it.
So if we were having DNS issues with the local Pi server, should we then also include here the second one that we set up in our PC?
Yeah, so you
area?
could do a space. Oh no, are these settings correct? No. So 172.17.69.133 and space, and then like if you did 8.8.8.8, right? So my hope with this setting, and the way I'm understanding this is I'm going to point my VPN server to my DNS server that I just set up, which is on the local machine, okay, to get the resolution. And the only point where we're trying to get it to do, the only thing we want it to do is we want it to see the VPN server record that we put in there so that it puts the right IP address in the config file when we create the config file.
Don't forget to separate them with a comma.
I just saw that. Thank you.
I'm sorry. Go ahead, Kathleen. I didn't mean to.
That's just what I was pointing out. Thanks.
Okay. So we're gonna tab.
Everybody got your back.
Yeah, that's good. I love having like 20 sets of eyes on this, and and you know all the brains that are here. Okay, so we're telling the server, hey, go look at the 133 DNS server, and the reason we wanted to do that is because that's where we put the VPN server record that gives the local IP address for the VPN server. Otherwise, if we had followed the instructions, it would use our public IP address as the point for our configuration. So then I wouldn't be able to connect to my server because it would want to go out to my public IP address, and we're not putting this on the public network, right? If you were doing, if we were doing, I'm reading the comments, sorry. If we were putting this as a VPN server at the, at the point of inbound for our network, then absolutely we would use normal DNS and we would use our external IP address, but we're not, right? We're using an internal one. So I'm like I said, I'm 90% sure that this is the way we've done it. And I'm 90% sure that this is going to be the functional way for us to make this happen. So I'm going to hit enter here. I'm going to confirm that these are correct. These are my servers that I wanted to use, right? And then this is where I don't want it to use the public IP address, right? If I use the public IP address, then I won't be able to connect to my VPN server. I wanted to use a DNS entry, which is why we chose the local DNS server that has the entry I want in it. Okay, so I down arrowed, I hit the space bar to select it, I hit tab to get to the OK button, and I hit enter. And then what is the public name of this VPN server? VPN server, right? That's how it's listed in my DNS records on this computer. Okay. So, all right, it doesn't like, it's going to go, I'm going to have to do local, right? So VPN server dot local. It likes to have the dots. So VPN server dot local is the local server or the local record that we're looking for. So is this correct? Yes, this is. The server key will now be generated. So this is going to create a server key for us to connect, right?
Okay, I was looking. What did you type in that public DNS name? VPN server?
VPN server dot local. Like, so that's what I named my server. That's the record. So whatever you named your server and whatever record you put into your DNS, that needs to match that. So this one, so unattended upgrade, which I want to see how this functions, because Unattended Upgrade is a other piece of the basic install that I thought would be really neat to set up. But when I looked into it, there's a little bit more complicated than just selecting it. But what Unattended Upgrades does is it's kind of like setting up your Windows desktop to automatically download updates and run them. So in this case, right, we don't really need to run them. Right, in this to me, this is a test environment. Like, we're not setting this up to be a permanent VPN server. We're setting it up to show that it can be done and try it out. If you were setting this up and it was going to be your VPN server that it was exposed to the internet, then you absolutely want to do the unintended install. So for us, though, I'm going to go no, so that we're just not messing with that component.
What if we don't have a no?
You don't have a no here?
I have an okay.
Yeah, okay. And then the next line has yes or no.
Got it.
The first one was an informational.
Got it.
We think you should do this. And then it says, you know, then at this point, I'm going to go no. We're not going to do the unintended install. However, I will point out that I'm really interested in understanding how that can be configured on a regular Raspberry Pi, so that I don't have to do the sudo apt update, sudo apt upgrade constantly. For today, no. We're going to go with no. So now we want to run Pi Vpn add to create. This is an informational thing. So Pi Vpn add to create a client profile, and we're going to do that at the command line, right? I think that's over here. It shows you click OK, and then you wants to reboot, and then we need to run that. And down below, we have the instructions on creating that profile. So we're going to click OK here. This is telling us that we need to run that to make a profile. Do we want to reboot? We absolutely need to reboot, so that the server, and OK again on this one, so that the server actually boots up as it is configured. Okay, so we've configured the VPN server to do its thing. We've given it we're hoping the correct IP addresses will show up, and we have a local IP address instead of the public IP address, which we told it to go to the DNS server to do that. So once this gets back up and running, over here on the right, we're going to go in and get into terminal, and we're going to run an add, right, which is going to have to generate a key. So hopefully we don't have, you know, massive amounts of time waiting for keys to be generated again. So I logged back in, right? So it went right back to the server once it rebooted, and I'm back into a terminal session. I'm now on the section of the tutorial called creating your first WireGuard profile on the Raspberry Pi, or on your Raspberry Pi. So we are going to utilize, it says right here, utilize the Pi Vpn script again, but we're going to run a particular piece of that, right? So sudo Pi Vpn add. This will allow us to add a profile to the server. So the name of the client, right? So at this point, we need to name the client. You can call it whatever. I'm going to just use my name, right? I'm perfectly fine with that. All right. So it successfully created the configuration file. Okay. And the file was copied to the home Pi configs for easy transfer. Right. Then we can generate a QR code where you can pop it with a QR code. We're not going to do that. This file is located there. So if I look file manager up here, if I click on file manager, right, it's in this configs folder. So that file right there is the file that I need to do my to complete my setup on my computer. Okay. So that one's there. So I think if we go Yeah. Okay. So what I need is a kind of like it ends like, okay, you got that. They're good. Like, so, if I'm not mistaken, what we need to do then is we need to get this file, the file that's right here. We need to get that file in the configs folder. I need to get that file onto my computer, right? And to do this, you can probably use a thumb drive if you wanted to. What I think we're gonna try, I'm gonna just use my email. So I'm gonna launch, Gmail real quick. I'm gonna take this off screen so I can type in my username and password real fast. I think I'll probably have to do a verification. So wait for that verification to finish. And then drag this back over here. That's new. When did they change that? All right, so then from here, I'm going to compose an email. Maybe, maybe not. We'll see. Something's not right. Why is it acting funny? I moved it over to reload it. I'll be back shortly, see what's going on here. Let's see. I just want to email myself. What is going on? For some reason, it's not just not launching a compose window. So my thinking was it'd be really simple just to email myself. Okay, so now it's doing it. And then I can get on my computer and I get the email and I just copy the file over. That's the plan, right? So that's what I was trying to do. So literally going to send it to myself. And I need to attach a file. and Pi configs. This is the file I want to attach. And this will be my VPN config. Okay. So this VPN is I don't think I would want to do this in the real world, right? Where this was exposed, or if this VPN was exposed to the outside world, I wouldn't want to attach this file and send it to myself. But if somebody gets this file, they'd have to be on my network, and then they're only connecting to something on my network. So I'm not overly concerned about that, if that makes sense. I wouldn't want to. I wouldn't send this file across the regular thing, because
yeah, because that file contains your keys.
Yeah. No, that's why I'm pointing that out. Like, it's not something I would send across a normal, in a normal day. This would be something that you'd probably put on a thumb drive and then copy that way, or use some other kind of more secure method, right? So there's that file. So then what I'm going to do now is I can close this off of the VPN server, right? And I can then just go to Gmail on my regular computer, right, and pull that file down. That's the whole point I'm trying to do. And again, we are behind. This whole thing is behind, right? My firewall. It's not exposed to the internet. I wouldn't have done that if it was an internet deal. Like, I wouldn't have done it otherwise, right? So then there's the file that I need right there, and it should be, verify that it's in my downloads folder real quick. Yep, so that's in my downloads folder. So we'll get to that in a minute. Cool. All right, so then that piece is done. So what I've done is I took that file that is the configuration file, and in this case, I sent it to myself via email, which is probably a really bad way to do things, right? I would put it on like I said, thumb drive, and then you can get that file to the person, or when, if it's in IT, like, you would set it up on the laptop before they left with it, or whatever the case may be. Okay, or come up with a secure way to get this thing passed along. Okay, my VPN server is up and running. I've generated a config file to connect to my machine. Okay. So you could actually try this, like, on your, like, if you wanted to actually do the code right here where you're generating a Q code, which will show you a Q code on the screen. You could use your phone to actually click on it to actually get the a VPN, and I don't know if your phone, unless you're on the same wireless, you would have problems with that. I'm going to use my PC now. So I'm going to set this aside. Like, I'm going to move the VPN server out of the way, right? You need a, so WireGuard client. So you need a client to connect to this system. Normally it's like it's usually just, so installation, that's going to be the actual device. That's not don't do any of this. This is all the, like, setting up the WireGuard. So let me try that again. WireGuard client software. I think Openvpn client would work. But I want to see if they, interesting. That they don't give you like a real quick way to get to the actual client itself. Let's go back to the instructions. Okay, so the other day, I know we just fired up, I think we went out and grabbed Open. You can find the WireGuard app. So there's an app that you can use, which that's not what we're trying to do at this point. So why? Why are they not showing us where the client is? I think I have, like, I've got Openvpn. Yeah, so I wonder if we just go that route instead of just try to WireGuard specific. Let's go Openvpn client. Client connect for Windows. It doesn't say it won't work. So I'm going to put this link over in the chat. This is for the Openvpn client, right? So this will be the VPN client that we put on your computer to then connect to the VPN. And I still think that I can't imagine that they didn't, like, they wouldn't just have, like, I don't see anything that's specific to being a WireGuard client. But that's weird. Is that weird? Am I being weird? Am I thinking weird? Like, what's this is all about like installing. Like, if I go there, is that the client or is that the, that seems like it's the application, not the actual client. But those look like clients.
I'm trying it on the iOS device.
Okay. I'm just like, is WireGuard installer. I'm downloading that. I'm just, let's see what this does. If it breaks, it's not my fault.
No Pis were harmed during this demonstration.
Exactly. So import tunnels from file. So okay, so I just installed I went to this page here. I went to the Windows page. So if you go to installation, that's this page. This is the WireGuard. Like, this is the WireGuard web page. I'm thinking, well, based on what I just got here, this looks like it is the actual. So to import tunnels from a file, right? I'm going to click on that, and I'm going to go to my downloads where I got that comp file, and we're going to see if this does it, right? So it looks like it's going to. Like, so this is carry, right? I don't like this. Dang it. What was that all about?
So I downloaded it and I'm able to use a QR code. It worked fine so far, but it says, interesting, it adds a configuration file and then says all network activity on this iPhone may be filtered and or monitored when using VPN.
Through the VPN, yeah. So if
okay.
Yeah. I think maybe this is the addresses that it's going to use. Let's see if this, yeah. So I imported that file, right? And I think what it's doing is that the VPN side, like the other network is the 10.6 number. I hope it is. I'm going to see, I'm afraid. I'm going to activate and see what happens. So, right, so it says it's been activated. It looks like I'm on. Yeah, so I'm on. Okay, so we haven't done any configurations of the VPN. One thing I will point out is now that I'm on a VPN, this network just dropped, right? My connection directly to the server or to the VNC dropped. And because we don't have a network built behind this, it's not like we can test and see how it works and what's going on. I think if you can get to the point where you have an active connection, then what you have successfully done is fired up a VPN. You've installed software, a client that allows you to connect to the VPN, and you are actually, at this point, with an active connection, I have a tunnel between my computer and the VPN. I'm curious to see what, so it works on iOS too. That's awesome. I love it. IP config. I wonder what IP config looks like. This is just me being curious again. So I've got a WireGuard tunnel right here, right? DHCP is not enabled, auto config. My address on the tunnel is 10602. So that 10602, that's the tunnel, right? That's the tunnel between my computer and there, okay? And then I have my normal network is still here, which is why we're still communicating, right? So I have my normal, my network address, but then I am tunneled from this computer to my VPN server. So if I plugged in on the VPN server, I'd have to go and do some configurations now, but I can plug in a separate network with different IP addresses, and it would allow me to go from one side to the other, and be able to, like you would normally do if you were in a small business or a company where you're connecting VPN, right? I'm going to connect from wherever I'm at. I'm going to create a tunnel to my network, right? And I'm going to get, there's an IP address that's given there, but then from the VPN server, right, the VPN where I connected, I would then be able to get onto on the network on the other side and be able to, print and connect to data and whatever the case may be, okay? Yes, no, maybe so. This again, like that's that kind of point where we didn't require people to have extra parts and pieces and extra network connectivity and things like that. So I don't want to push past this from that standpoint, because then, everybody who's able to participate up to this point, we'd start, we'd shed even more people. And I don't, at that point, we only have a couple of us that can go beyond it. So
I got, whenever I start up Wire, whenever I click the activate button, I get no such host is known. Or if I look at the log, resolving DNS names, unable to resolve one or more DNS host name endpoints. No such host name is known.
And I'm trying to think, is that a DNS config problem? Is there something in the way we created the config?
The only thing I did different than you did was, well, and actually it's not there. I mean, I used for the secondary DNS on my PC, I used that. You remember whenever I set this up, I had that issue where, I couldn't. And so I went back and put in 8.8.8.8 as the secondary DNS server. So I'm wondering if maybe there's something
in the config of the DH
server,
of the primary DNS, and then it defaults to 8.8, and when it goes there, it doesn't see anything local, so it doesn't respond the way it's supposed to respond. That's a possibility. It's, definitely a possibility.
Now this is interesting. Where I go back to the DNS server we set up on the Pi. Whenever I do a dig, it tells me 45 seconds. So it's like it's not pulling anything local. And whenever I do it again, it's 0.
Yeah, and we saw that happen last week too. Like, it was weird. Like, you would, if you were on the local machine and you did that lookup, it would do the 45 milliseconds, and then it would do it again, and it would get 0. And then we would test it from I redirected my PC to it and ran the test again, and it gave me 56 milliseconds, and then I did it again from the PC and it gave me 0. It's like it kept the cache for, if you did a local query, it's one thing, and if you did and I don't think it works that way, but it acted like it, because it was another machine asking it, like it needed to do the cache over again or something. That was really weird. Like, it shouldn't have done it. I don't feel like it should have done it that way. Like, that information was already in cache. It shouldn't have changed. But or maybe it has a really tight timeout. Like, if which would be really weird. Like, why would you cache something and then time it out 20 seconds later? I don't know. That maybe it cleared. The cache cleared in the time between the two different tests?
I think I just figured out my problem. I have a
Okay.
spelling error.
Ah, okay then.
Let me see if I can fix this. Let's see, I've got to go to the host file. Because if I put that in the wrong, no, it's right there. Let's see, where else did we put it? You know what? We put in the server name in the WireGuard configuration.
In the WireGuard config, yeah.
Control X. So let's see, to get back there, how would I redo the WireGuard configuration?
I think there's probably a config file that we could change, but I don't know. In the past, last time when we had a problem on our config, we ran the config over. So,
Right.
which, we should, let me look up. Why am I missing? There we go. Browser.
Because that command was just the install Pi Vpn IO. So if I go through and run that again, we're going to repair using or reconfigure with new settings. Okay. No, that wasn't it. Okay, the reservation is the same. Yes, keep the DHCP reservations.
And so, and then I'm going to copy this tutorial over, not because we want to go through this one, but this is from UpCloud here. This one here, they have like setting up the port forwarding, and they have setting up firewall rules like on your VPN, right? So on the WireGuard. So there's some other things that can be done after the fact. I'm wondering though, like WireGuard quick config, there's public key, private key, WG0conf, is that the file? Generated server config. So Etsy WireGuard. So Etsy WireGuard is where the file's going to be. VPN. Oh, I can't connect. I'm going to disconnect my WireGuard. Deactivate. And reconnect, hopefully. Yeah. So here's my server again. So I'm just curious. So cd / not there. Etsy WireGuard. Nice. It won't let me get there. That's awesome. It's like, no, you can't make configuration changes. Permission denied. / Etsy. And then ls. And then cd WireGuard. Spell it correctly. That'd be good. Permission denied. Yeah, it's not going to let me get into the WireGuard config file now that we've got it up and running. That's interesting. I have to play with that a little bit longer or a little bit more. So I did like this extra UpCloud stuff I put out there just to kind of, if, you know, for tweaking and playing around and doing other things later on, kind of see. Ours seems to be pretty, this one's pretty straightforward as far as just the straight up installation of it is concerned. But I would imagine, yeah, there's going to be some kind of a config issue along the way if you disconnect, if you can't get connected. For those that have tried to make this work, it looks like Kathleen got it working. I know, Tony, you got it working last week, right? And David got it working last week.
I have it on the iOS,
Yep.
not on my Mac.
Okay. The Mac is not connecting, or?
No, but I've got it crazy because I've got like 3 VPNs already on here.
Oh yeah, don't mess with it.
I think I have to add the certificate. It looks like I have to add the certificate into the Apple Certificate Manager.
Oh my gosh, okay.
Yeah, so it's not quite so simple. But it's good to know because our students have Mac.
Yes, exactly. All right, excellent. Anybody else working on it, tried to get it working? Interested in watching how it worked? All right. I'm not seeing any responses, so I'm thinking everybody's okay with where they're at. I hope so. I don't know that we could get anything else accomplished in 47 minutes. So, as far as anything new, we can one thing I would, because I know there was interest in the wireless access point. And we won't do that one, but I'll point it out. I should spell wireless correctly. That'd be good.
One of the things that I don't know if there was a better list of the student IoT projects that were created. I was interested in seeing the or just a link or whatever to the there was like either a garden monitor or nutrient doser. I'm a technical advisor for our local community college's horticulture department, and they wanted some Arduino devices, so I did a workshop with Arduino and a temperature and humidity sensor. So anything like that would help give them some better ideas, I think. Give me some better ideas to support them.
So yeah, so there was can we demo something that maybe some hardware we don't have? And then like David, kind of on the same kind of vein. So what if you don't mind, I can show you a couple more of those projects, right? So you can at least see what students have come up with and what they've built. And there's some specifically related to what you're talking about. I'm going to stop the share because I don't think I shared sound when I did the share this morning. So I'm going to stop the share, right? And then I'm going to redo the share and I'm going to add sound this time. And I need to go find, so this is the fall. So I wonder if there's any one of these are good. So we also do stop motion video as part of the class. I'm trying to think if there's any ones that were like just crazy fun. Oh, I'm going to use this one's only 10 seconds. So these are really short videos, but I really think this was interesting because this is a student, right, who has a daughter, and he got his daughter involved in the actual like making of the project. Right, so just kind of really fun, like, so, and there was a couple of places where I had students that have kids, right, and they're what they're learning in class, they're now sharing with their kids as well. Let's see if there's so I would assume, knowing this student, that this is a pretty good one. Yeah, so right, so these are little stories that they built, right? So the assignment is we connect a camera, we teach them a camera on Tuesday, we teach them how to use the cameras on Tuesdays, and on Thursday they come in. Normally we do this as a partner thing, and I bring in a big box of Lego and they build things, but because we're at home, everybody had to do their own project. But you set up the camera to do stop motion, and basically we write a little piece of code that's in a loop. It runs 75 times. You have to do 75 pictures, and then you set up the camera with a button. You press the button, it takes a picture, you move things around, you take a picture, move things around, take a picture, and you create these really neat videos. And then there's software, the FFmpeg, MPEG will allow you to then take all the pictures and make them into a video. So this is one of the activities that we would do in class, where they're physically connecting cameras. They have to learn how to make the camera function with the computer, and then they from the Python that we teach them, they have to build this nice little loop that involves a button. So they have a button connected, they have a camera connected, and then they have to do something creative with that, not just simply take a picture, right? Which a lot of things will be that way. I'm looking for final project. So that's fall. Here's the spring. No, that's the spring stop motion stuff. Hold on. Let me find the final. These are the projects from the spring. Oh, we had very few. We're going to use the fall ones. Most of the ones in spring posted their stuff to YouTube, so we have a big list that they could go look at. And then I think on here, like here's the greenhouse monitoring. This is a plant one. I'm looking for one. I remember there's one that had a really nice setup in his kitchen. And which one is it? I like the parking sensor one. That's a pretty neat one. But I know there was why am I missing it? Plant monitoring. Hey, kiddo. Greenhouse monitoring.
There was something that said happy plant at the bottom. I don't know if was another one.
That's exactly the one we're looking for. Thank you.
Yeah, up a little bit. There it is.
Plant's happiness. I believe that. So this one's it. So I'll let this one run.
So the reason why I chose this project is I actually built this shelf several years ago to help my starters in the spring. So I had the lights and everything. And I've always talked about growing plants throughout the year, mainly not these house plants that I'm using as my test subjects, but growing herbs or greens in our kitchen, and doing things a little bit more automated. The lights are no big issue, automating lights. I can get a Wemo or an internet-enabled, power plug, and then set that in there. I mean, those are just, dollars now, $10. You can get one of those or so. So that's not a big deal, but keeping track of the plants in terms of their health and their feeding and their watering I wanted to maybe investigate that. And this class gave me a neat background that was directly applicable towards maybe doing something like this on my own versus going out and buying something commercially. So that was the main motivator for why I chose this project. It's because something kind of I've always wanted to do, and I like plants. And me personally, I'm not the one that grows plants and makes them look this beautiful. That's all my wife. So if I can help her, that's a plus. So the project, looking at the physical computing components, of course, this is the brains of the project is a Raspberry Pi. I have the Raspberry Pi in this little enclosure, and I have that enclosure kind of thermally regulated. That's where it does the kind of command and control. I'm using GPIO pins that will connect to a relay, and using the USB interface to connect to the Arduino, which is monitoring some of the sensors. Right. The other parts of my physical computing components, of course, I have the Arduino, and I put a sensor hat on there, basically a sensor shield, expansion shield. I have analog sensors that come out of here, and I'll highlight those sensors. I'll show them more up close in detail in a second. Those are my soil sensors, moisture sensors. The GPIO pins come out from my Raspberry Pi and are controlling this 4-channel relay. I have 12 volts coming into the common, and when a relay fires, it'll close the circuit, right, from the open to the closed side, and send 12 volts, which these are the connections over here to my pumps. So physical computing components are, again, the Raspberry Pi, my Arduino, and my something new, right, that I added to this, of course, is the 4-channel relay and the level of sensors. I have moisture sensors, and my actuators in this term are pumps. So I actually have water pumps that I'm doing, and I'm doing altogether 8 connections, right? 4 sensors, 4 pumps. All of this, of course, and I'll show the pumps, feed down to the submersible pumps that I have inside of this container. The wiring is marine grade, so as are that. You're not going to be able to see them as I have that. This container is good because it will kind of prevent icky things from growing in the water because it's dark and a little bit harder to see, but everything's inside of there. And then, of course, silicone tubing that goes through, and the sensors that I'm using, I'll pull this sensor down here. It's a little easier to get to, are from, DF Robot. These are capacitive analog sensors, and it'll let us know what the moisture level is based on the reading. So the higher the reading, the more resistance there is in the soil. And when there's water, there's less resistance, and it has a little bit lower readings. So in terms of coding, of course, I use Python. I basically have function, and I have some code that will, of course, calls that function, and the takes care of the logic on the sensors, where the sensor's at, cycles through the sensors, stores data in terms of where those sensors read, if things need to be watered, and it builds a notification, and I'm using IFTTT to send us notifications. So the Raspberry Pi, as you can see, I had some Wi-Fi connectivity issues with the Pi on its own. It was dropping Wi-Fi a lot. I had this laying around, so I connected it. I haven't had a single drop since then. So it's connected to my home Wi-Fi, and through the code, it's in turn using services on the internet to send notifications. The creative element that I'm doing, the fit and finish, of course, I guess my wife and I don't really want something in the house that's going to look industrial, so we wanted something that would blend in and look as clean as possible. So not having an industrial enclosure for the components was kind of important. So we repurposed this old tequila box to hold the components. and just try to make everything as clean as possible. And again, have like a nice semi-attractive, water container that's usable for purposes. So again, not very obtrusive. It kind of can go, unnoticed in the kitchen. And people just look at that and don't even realize what it does and what it's for. In fact, they may be curious and go open the box. The new element, of course, that I talked about is the level of sensors that I added for capacitive soil sensors and the actuators of beam pumps. We didn't work with pumps and higher voltage, so I had to use 12 volts DC. The build process was pretty straightforward. You can see that nothing's very overly complex. It was just the connection to the relay, the connection to the Arduino, and setting things up and connecting things so they would work, and testing out the pumps and testing the firing of the relay and the code. But where I ran into problems, I mentioned the Wi-Fi, but that wasn't the biggest problem. The biggest problem was originally my intent was to have the water up here. And when I did my test, the water kept flowing after the pumps turned off. And that was a big issue because it would flood. And I thought it might have been a defect with the pump, that the pumps were still working, but they weren't. And it's just physics. I'm not a fluid engineer or know much about that, but I did some research, and that's something called siphoning. So it's just the law of physics. The water level has to be below where the feeds exit these tubes to prevent that siphoning. So I had to change the configuration. That in turn forced me to extend the cables. Now, speaking of extending cables from some build perspective, you can see right here at this level, that's just the commercial length of these sensors when they come. None of that is practical. All of my sensors had to be extended. And when I ran into the problem with the siphoning, I had to redouble and triple the extension for the pumps. So those are some of the major problems and some of the fabrication things that I had to do in order to get this working and in place.
Really cool project. Nice
now
video.
Watch it work. This is really good.
So are you going to teach us all this in your IoT?
It's on top to a cron.
Some of it we do, yes.
And we'll go off here in a minute.
Like, do I have to study before because I'm not an electrical engineer?
So the first plant has been
you
sensed.
don't need to study.
It's moisture level through the moisture sensor, deemed dry. The pump had just fired. It's going to sense in order the second plant, and then the third and the fourth on the bottom shelves, and those pumps should also fire. After the cycle is complete, that's the second pump, I have notifications integrated with IFTTT to send right now an IFTTT notification, but it could be an email or an SMS text or whatever I wanted to do in the future. That was the third one. So we have notifications. Now I have my phone, and we're going to wait for a second. It was right there. So there's the notification from IFTTT that my plants are watered. So I'll expand that, and it says basically that my plants were watered, at 1:55 p.m. It's still 1:55. If the plants are okay, they wouldn't be watered. The pumps would not fire, and it would go into the okay. So I'll demo that next. So now, based on how well I water, I'm running the same test, or running the same cycle, but this time I did do some watering. So let's see if the sensors trip or if they think the plants are well watered. So somehow
right here,
plant 1 still thinks it needs water. It's sensing plant 2.
This tube here, it won't water.
Doesn't look like plant 2 fired, so obviously I might have watered that one well enough. It's moving on to plant 3 and plant 4. Again, none of those are tripping. So now what I'm looking for is that notification, which I just received. We heard the click. So we should only have one notification that a plant was watered. So we can see there,
one was watered.
Being in focus.
There you go.
That at 1:59, only one plant was watered. We heard that go off, plant 1. And plants 2, 3, and 4 were okay. And they didn't fire. So that's the system as it'll work in real life.
So yeah, so that one, right? One of the more, and I think like the electronics that he was working with, the only thing that we didn't cover in the class, which he mentioned, was one of the parts of this final project is to use a new element, something that we didn't cover in class. So that wasn't, and it doesn't have to be a massive, thing that's different. It just needs to be something that we didn't really do. So that and the idea of that for the final project is that I stretch the students, outside of that box of here's, this is the only thing we did. So he used the pumps, right? And he talked about the 12-volt pumps. So at that point, he had a relay that he had to add. So he had to figure out the relay, and a lot of students will add relays. We do a relay assignment, but it's not where we add the extra 12, to add 12-volt power to it, or run like a fan, which would require you to run to connect to 115. So a lot of students will use a relay because they're kind of familiar with it, and then they, with a little bit of research, in a couple of YouTube videos, they can figure out how to wire up, a fan or a pump or whatever like that. So, but we do in the class, in the IoT class, we do cover kind of the low voltage wiring, and let how how electricity moves around and the triggers. In that case, he's got sensors, like he mentioned. The sensors, they have Python libraries that connect to it. So then it's going to be based on that. So you learn, some basic electronics, you learn some Python programming, we gather sensor data, we have sensor data trip or trigger other events. And then he showed IFTTT, which is an online service that we would use to, in his case, he used it to trigger a notification to his phone. We do a project in the class where we actually use IFTTT to post sunrise and sunset to a Google Calendar. So there's all kinds of things that we would do within the class for that. So lots of good stuff there. But yeah, that was one of the really fun projects. The other fun project from this grouping, there's a bunch of them, but the one, I think I mentioned it earlier, and I don't think it's a very long video, is the parking sensor. This is about 9 minutes.
I need that on my patio.
The watering system. Yeah, there's another one. I don't know if it's in here or somewhere else. And I think in a previous course, I think it was maybe, I don't know if it was the summer, or I can't remember where it was. But there's, I have a video of a student that they live on the other side of the mountain. So we have, Albuquerque has a big mountain next to it, and then on the other side of the mountain, it's more like kind of foresty and it's more foresty, and they're up in the mountains, and there's more snow, and they have attached to their house, they have a greenhouse, and it uses solar panels to heat water, and then they would have to go out and manually pump the water through into the barrels to keep the greenhouse warm. And he actually built an IoT system that did all of that automatically for them. And then he presented it as his project, and then like a month after class, he sent updates, like, because he kept working on it. Like they're using that system to maintain their greenhouse over the winter, which I think those are totally fun. So let's do this one more so that you can kind of see kind of some of the creativity of these students, and then I'll take whatever final questions you have or comments, and we'll wrap it up.
For my final project, I decided to do something that was a little bit of a combination of all the things that we've learned throughout the semester in our class. And what I decided on is my garage is actually relatively narrow when it comes to how much space I have to park my vehicle. So currently I just sort of have it set up where I have a piece of wood or lumber on the floor of the garage, and when my tire hits that, that's when I know when to stop. But I thought through our class that it would be more interesting and technical if I built something that detects how far I am from the end of the garage and gives me a visual cue of when to stop or when to start slowing down. And so I did that, and with a combination of a Raspberry Pi, LEDs, a ultrasonic distance sensor, and a Arduino that is hooked up to a temperature sensor. That was put in place also so that I could monitor the temperature of the garage and know if it's actually getting below freezing, which could cause a problem with some of the stuff that I have stored in there. So that's my project, and I will show you exactly how I put it together as I move forward. So this is the setting that I was talking about, where I only have a little bit of room, mainly because I have my scooter that's sort of at the very end of the garage, and I have to somehow squeeze the front of my truck and not hit it, because that would be bad. But also I only have about this much room between the garage door and the back of my SUV. It's just a piece of lumber on the floor of the garage, and when I tap it with the front wheel, I know where to stop. The problem is I have to be very, very close to this wall in order to tap this and make it so I stop. If I get any closer to the right-hand side of the garage, I'll miss it, and then I'll just run into my scooter. So I set up the sensor, Raspberry Pi, and Arduino in a kind of temporary makeshift setup until I come up with a more permanent solution. In an effort to not distract us, I've just paused it. The yellow LEDs will light up when I start to get about, I think it's like 300, and I believe it's in inches or millimeters rather. The way the sensor works, it's kind of an arbitrary set of numbers that I get read back, and they kind of fluctuate, so I have to do these windows of numbers to determine where I am and what that distance is. As it gets closer, though, it gets a lot more accurate. It's just the farther distance, it'll start fluctuating a little wild. So about 300 is mainly about halfway into the garage, and then as you get closer and it starts counting down farther, it'll get to about 80 or so, and then it'll trigger the red lights. And I know once I've passed that threshold, that's when I need to stop. So I put the lights in a way that I could see them from the windshield or the driver's seat of my car. And so these will be easy enough and bright enough even during the day that I can see them, because it's far enough in the garage, sun won't wash it out or anything like that. I thought about originally putting it on the wall behind me, but that's a little hard because I have to stop looking where I'm going and I would have to look at the wall, and that wouldn't be useful. So I decided to put it directly in front of the vehicle so that as I'm driving, I keep my face forward and I can see everything that's going on the entire time. So the sensor is set up right here. It is an HC SR04. So this is the more advanced ultrasonic sensor. This is the 4-pin. There is a 3-pin. I don't have access to it, but I have read that it's not as accurate as this 4-pin. So how this is set up is I have the ultrasonic sensor mounted to its own breadboard, and each of these cables that are directly behind it correspond to a certain pin out on the sensor. So the black here is ground. The blue here is, I believe, the VCC. So actually, sorry, that's the Echo. So the Echo will then connect to the Raspberry Pi behind this. The yellow is the trigger, and the red is VCC, which is also basically the power to this. So what happens is it gets directly mounted to, and I'll just unplug all this to make this easier. So it'll get directly mounted to the Raspberry Pi. And so black goes to ground, red goes to the power out, and then the yellow and blue are GPIO pins. Pin 6 is the main pin that really does most of the sensor reporting back to the Raspberry Pi. So on addition to having this ultrasonic sensor, I wanted to have a temperature sensor that also monitored the environment of the garage and let me know if it gets too cold or too hot. Originally, I was trying to get it to do a direct connection from this temperature sensor here, this guy, to the Raspberry Pi. Unfortunately, this version that I have is one that I can't just connect directly, or I just couldn't find out how to direct connect this to a Raspberry Pi. And I think it's because it lacks some of the features. Like, it doesn't actually have what's the word I'm looking for? It doesn't actually have a port out when you try and connect it to the Raspberry Pi. It won't show its port ID. And so what I had to do was decide, hey, how can I still make this work, and how can I... Oh. Can you stop? Maybe the door is open to the garage, because that's way too cold. Or the other thing is, if it's over 105, to me that's way too hot, and something needs to be done about the garage so it can cool down, because if it's over 105 degrees, things can start melting, or plastic, and stuff starts going bad if there happens to be food or anything like that stored here. So those were important thresholds that I wanted to monitor as well, and that's mainly what I have. So to give like a better representation of what it's doing and not from inside the truck, I'll kind of show you, as it'll detect even a person as it walks up or closes the distance. So after you get about halfway into the garage, the yellow lights will turn on, giving you a visible warning that you're getting close. And then as you keep getting closer, because this tends to be about, it'll get to about 90 or so. Of course, I'm trying to do this while looking at the camera. So, and that's about as close as the truck gets as well. It gets pretty close to the sensor. So that's how that works.
Oh yeah, so there you go.
Nice.
Right, it's just, they come up with really neat, creative things. Along the same ideas, one of the students, and it was a previous class, he set up to Siri, right, where he asked how to open the bomb bay doors, and his garage door would open, right? So he actually connected relays to his garage door, and then connected to his Siri on his phone, and was able to close and open his garage door by talking to his phone, stuff like that. So and got the magic mirror kind of things. I mean, there's a ton of stuff, obviously, but those are just a couple of examples what my students did this last fall. I don't do that class in the summer because I really want them to have the full 15 weeks to get things accomplished. Otherwise, we kind of rush through things, and there's a lot of material again in that class too, just kind of getting through the learning Arduino, learning Raspberry, learning programming, learning some Linux, learning some command line, learning the sensors and how they connect, and then we connect them to the internet, and we start interfacing with API keys and all kinds of other fun stuff. So anyways, there's just a couple of examples from the physical computing side of what students have come up with that were pretty amazing. I've had one thing that kind of, when Kathleen had asked, do I need to be an electrical engineer? It's like, well, we don't. We're going to learn enough to get, to make a fun project. But I've had students, there's a couple of projects where when they showed up and delivered their projects, I was like, I don't think I could have built that project. Like, they were like, they had other skills that and one of them was web-based skills. Like, he literally built a dash camera that was in a cigar box that would, he could just mount on his dash, plug it into his cigarette lighter, and when he gets home, he would take the Raspberry out and plug it in the house, and it would automatically upload the videos from the day to a web server in his house, and like, just crazy. That was totally cool. Type of stuff. So I love that day every semester when we, my fall and spring semester, I love final project day because you just get to see these creative projects that they come up with and build. I have one guy, and I wish I don't have a link for it. I should have brought it up, but he built a security bear. He took a stuffed animal, like a bear, a teddy bear, and he actually mounted a camera in the eyeball. And then but he also had it was like a farting bear, like it literally, and he did a test on YouTube with some kind of canister of, fart spray or something. And he about killed himself. It was gagging so much. And he recorded the whole thing and then shared it with class. And like, it's hard not to laugh, but I'm like, oh my gosh, the things my students will do to get this project done. So, subject themselves to fart spray to make it happen. So it was, just like all kinds of fun things like that you're going to run into. Are there any questions at this point? Like, we're kind of wrapping up. We got 12 minutes left. Officially 12 minutes, right? We can pretty much end any time, but we've shown you, I'm hopeful we've shown you a whole bunch of things that we did this week. We did networking this week. We did web this week. We did database. Right, we did all kinds of Linux type activities, configuration activities, system administrative activities, the web admin, and that console piece. Obviously we didn't do any physical computing, but you can see from some of these examples that we showed you, like, we literally could have spent an entire 3-hour block just watching the videos, right? Because some of them are just amazing. And right now they're all, because they were students submitted, I have them on a Microsoft Stream where it's not available to public. I'd have to get permission and all that kind of fun stuff. So and in this kind of environment where it's contained, I'm not overly concerned. But if I were to start posting all these out onto the web, I think CNN would probably have a cow. So we're not going to do that. But I'm hoping that you see like this, the potential. And I honestly hope that something that sparked this week becomes an obsession for you later on this summer, right? They're like, you just want to, you want to figure something out or make something work or whatever the case is. But thanks for hanging out with me and spending time with me this week. I think I had a lot of fun making this happen. And
oh, for sure. This is always exciting. I talked to my brother yesterday. He's the Mesa Club advisor, and I'm just like the technical advisor or whatever.
Nice. Yeah.
And he said that the regional UCSE head of Mesa, UC Santa Cruz, had a whole bunch of extra money, and they just spent it all on Raspberry Pis and like Vilrose stuff. And he's like, "Oh, so you're doing that class?" And I'm like, "Yeah." He's like, we'll run the thing for the students, and we have all sorts of gear." And I'm like, perfect.
Yay, let's do it. I like Santa Cruz.
We'll see you here next time, or whenever we can finally get back to doing stuff.
Absolutely. I will be the first one to sign up for that mess. So, I love it.
Yeah.
I love coming out and visiting. Awesome. All right. Does anybody have any questions? You're able to email me with questions anytime, right? So Carrie@Bruce@gmail. You can go kbruce@cnm, either one of those. Carrie@myitinstructor.com. All of those will work. So any of those are great.
Yeah, I really like Kathleen's idea about, collaborating afterwards too. I think
yeah, absolutely.
I think these projects are phenomenal, and my students did a couple of different things, but I think that we should have a central location, and ask our students, let's share them, because I think they're so helpful.
Yeah, they're great. They are really great. Like, I remember even back, like the very first time I ran this class, we did mini group projects, and one of them was a twittering photo booth that ended up being like a normal thing. And we would actually take the booth to activities. Like we took it to the Halloween carnival thing that they did, and they had this big electric chair that the people could sit in, and they snap pictures and they show up on Twitter. We had another hummingbird, and we called it ghetto because we were in a hurry, so they put the Raspberry Pi with a battery pack in a Walmart bag and hung it from a tree with a camera hanging out the side on a hummingbird feeder, and we actually captured hummingbird pictures as these birds were, so it doesn't even have to be fancy. Like, you don't have to do the fancy videos to do this. Literally, we threw a Raspberry Pi into a Walmart bag, like a plastic Walmart bag, and hung it from a tree.
So I have a project I want to do. I'm a Doctor Who fan.
Okay,
and
great.
There's a guy who he actually did his dissertation on this. I actually got a copy.
Oh my gosh.
He took Raspberry Pi and Arduinos and made a canine dog, electronic dog. Okay. I want the same dog, but I don't want to repeat what he did. I want to do it with a smaller version and have it when I go to all the events to follow me around, and take the iPad, iPad LCDs or laptop, and make that interactive with the dog.
That'd be cool.
So that's my goal.
Totally awesome.
You have to teach me enough of this stuff all.
Okay.
Okay.
Sounds like a plan. Let's do it.
Okay.
Let's do it. All right. Excellent. Cool. Again, thanks for hanging out. I'm gonna get access to first of all the videos. So Monday's videos I uploaded last night. Laura has those. She's gonna put them in the resources page. She's also gonna give me access to get copies of everything. So I'm gonna download that and put it on our Google page. I am gonna take a break next week, so you got to give me a little bit of time, but say probably 2 or 3 weeks out. I'm going to take and get all of the links and everything from all of our chats and all of that kind of stuff and put that into our Google document. I'll send everybody an email that those things are out there. And so that you can get access to all the resources. Plus, I really like this idea of continuing on with a user group of some sort that's specific to teaching, using the Raspberry Pi to teach these, and I say CIS concepts, right? Because I think CS and CIS they're different, right? And I'm more of that, like what you saw this week, like more of this building a system and all these kind of things. Like, I think the Raspberry can work in both situations, but the idea of like having university instructors and community college instructors working together to have examples of things that we can do for that level of student, right? Because I think most of the resources you find out there are going to be primary school, secondary school related, high school, middle school related, and we always have to kind of adultify them a little bit, right? Just to kind of make them more interesting to to the students that we deal with on a day-to-day basis. So I look forward to doing that. It's not going to happen the next couple of weeks. So right, if that's the goal, I apologize. If that's the expectation, I apologize ahead of time. It's going to be a little while before I get.
You got to relax, enjoy yourself.
I'm going to try. So, we're going to go hang out in the woods. So that'll be nice. All right. Excellent. Well, then with that, have a great weekend. What do we have? Juneteenth this week and Father's Day this weekend. So for all those of you that are fathers, happy Father's Day. And for all you women that made fathers, thanks for that too. So, yeah, I'll see you somewhere along the way. We're going to do, I think we're going to try to do some Twitch stuff. I'm definitely going to be doing more classes with WASTC. I'll be doing the winter conference. So I'll do workshops specifically in the winter's conference, and we'll do workshops, hopefully in person next year. We'll be doing these in person. I'm excited about doing maybe a TensorFlow, maybe doing some robotics around the Raspberry Pi, right? So some kind of topic specific things where we immerse in just that topic instead of trying to, I love to kind of doing all kinds of things, and that will always be the baseline, but I think they're kind of digging into specific things are going to be fun as well. So yeah, I'm game for all of that. We'll figure it out. All right. So have fun, enjoy. And,
thank you, Gary.
Yeah, have a great
Y'all
weekend.
don't forget to fill out your survey.
Oh yeah,
the event and the workshop.
Yeah, there's a survey. I guess you got to go back. I haven't even logged into that page because I just have a link that Laura gave me that fires up these meetings. So yeah, go out and do the survey. Let us know what you thought, and we'll go from there. All right.
Thank you, Gary, very much. Bye.
Enjoy. Take it easy.
Thanks so much.
Hey, man.